All right, shortcuts. We like shortcuts, right? So if we're creating Taylor series, there's a pretty useful series of things you can do, which you already know how to multiply and divide and add and subtract. You know how to integrate, and you know how to take derivatives. So we're just going to use those to create new Taylor series. We kind of started to do this with power series a little bit, but this is where we kind of zero in on what you really need to know. Okay, so we just did our memory cards for e to the x, correct? What was the Maclaurin series? E to the x. And that means 1. What's the polynomial? Plus. Okay, right? So so like I said, most of the time you're going to want to know the polynomial. Sometimes they throw at you to see, find the series. So this was, now what about Maclaurin series? For x squared e to the x. It's just a multiplication problem. This is not a derivative, so we don't need a product rule there. We can just continue it, right? So just distribute it. X squared plus x cubed plus x to the other way to do these, okay, I do the easy way, right? Multiply. You can also insert it in here. So we would be, this series would be what? X squared times x to the n, or n factorial. So not a whole lot to edit. You can also write a different series for that if you want. You don't just have to edit this one. So lots of ways to do these. But I suggest you just keep it simple. Like that. Next. What about this one? You write in series notation. If e to the x has an x here, correct?
Yeah.
So what am I putting in that place? This is a substitution problem. So everywhere there's an x, I put negative x squared. So if we go back, everywhere there's an x, I put a negative x squared. Okay. So it's going to be 1 plus negative x squared. I always want to put it back for that. I don't need So that's substitution. Just direct. Nothing new for you, just plug it in. You can, obviously you can simplify that, and it does become 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th. Do where the sign change there, it does become an alternate series.
But it would be okay, Sam, if yours wants,
Just leave it. Leave it. Yeah, you're probably gonna run into something like this on this one, some way, shape. Whether it's, what is the series for sin x, you can just view that on paper like I showed you last week, or, you know, what is the series for e to the x sin x. Okay, we can find series by integration as well. This is where it becomes most useful. Let's find the Maclaurin series for f of x equals to the natural log of 1 plus x. This is one of our memorization ones, right? Yeah, okay, so if you want, you don't have to memorize it. Why? Natural log of 1 plus x, the integration of that. Right? So if I know the 1 over 1 plus x series, I integrate term by term, and I have my natural log 1 plus x. So what is 1 plus x? What's the series for that? 1 minus x plus x squared. Do you find it eerie how similar a lot of these are? There's not a whole lot of difference in a lot of them. Yeah? It can, yeah, it can. If there are any, I'll see if I can think of some patterns. I haven't really put the time into that. Like we did, you know, sine and cosine and stuff, all those have patterns to them. This might too. So if we integrate both of these, out the backside, we should get natural log 1 plus x, correct? X. Is that right? Sure hope so. Yeah. So there you go. It's another one. Integration. So this would be an integration shortcut. We've multiplied. You could pray to God that they don't ask you to divide. Synthetic division, long division, all of those. No way. So we've got multiplication, and I showed you substitution, integration. Let me show you a little bit more of an involved multiplication and kind of a shortcut I found with it. Let's do write out to degree 5 e to the x cosine x. Whoa. Write out the terms of degree 5 of the Maclaurin series. Or e to the x cosine x. Big giant multiplication problem, right? Okay, e to the x. Is that 1 plus x squared over 2 factorial? Is that, okay, hopefully we get that one now. Notice it says degree 5, so I'm going to write out to degree 5 for each of them. Okay, just to be safe here. Okay, that's e to the x. Now let's cosine it. One minus x squared over 2 x to the 4th. I don't need to go any further because the next one is to the 6th power. Okay, if I'm only asked for degree 5. Now, who wants to multiply that up? Yeah, that's what I thought. There's really, the nice thing is when you get to 5th power, you stop. Okay, so I'm going to just take each term here and I'm going to multiply it in. Okay, so if I took the 1, I would multiply it by each of these. Staying organized. All right. 1 plus x. And I'm going to put the denominators as the actual numbers. Okay, so that's the first one, right?
Could you leave it in the simplest form like the very first time? Or like that previous times?
Because I want to get it done, but we'll simplify it out in here. Okay, now the second one. Take it in here. Do I need to do all of them? I'm going to stop right here. Because that's where it hits the 5th power, right? So these two I won't even need. Because it goes above the 5th degree. So minus four. Right? Then I'm going to stop because that's degree 5. I don't need to do the other two. X to the 5th, and that's 6. Right. And now we do the last one. Okay, this one, we're going to have a 4th power and a 5th power. We only need to do 2. So plus x to the 4th over 24 plus x to the 5th. Right, so it's a big nasty mess, right? Kind of. Okay. We have 1 plus x, right? Okay, x squareds, they cancel out. What about the x cubes?
Yeah.
So they have different denominators, so you have a common denominator. So this one is actually 3x cubed over 6, right? So 1 minus 3 is negative 2x cubed over 6. Negative x cubed over 3. All right, so those are done.
Well,
Now, what?
would you want to put that all red? Would you put it like minus and all in parentheses?
No, I put minus on every term. It's a multiplication problem.
Okay.
All right, that's done. Now the fourths. We've got 1/24 and 1/24 and 6/24. So 1 minus 6, -5, -4 over 24. And then the fifth powers. What'd you get for the fifths? -10. This one is -quarter, 24. Is that right? Sounds about right. We got our fraction math here, huh? Check our answer. Oh, 120. Yes, there we go. So it's going to be 30. I changed my denominator. So there you go. Multiplication problem, it's just a little bit longer. Your book does have a different method in it. I couldn't figure it out, honestly. I didn't put the time into it. This is what I'm used to method. Okay, one more. Let's say J is this. We're just going to call it J. Express it as an infinite series. Here's sine x. And then we'll make sine x squared, right? There's sine x. This is a different way to generate the series for sine x squared. Last time we wrote it out as a polynomial and plugged x squared in. I'm going to show you this time how to do it. So sine x squared is x squared in here, right? What is that x going to become then? And what does that become? You don't have to write.
4 plus 2.
Yeah, 4 plus 2. You multiply these. Remember your properties of exponents. So x to the 4n plus 2. Here's the really neat thing about these. When we integrate, we don't have to worry about any of this. This is all we have to do. Because this is all a constant. It's a number, right? All we're integrating is a variable. So, little tidbit there for series. If it doesn't have an x in it, you're integrating its base So what's the integral of x to the 4n plus 2? You integrate power rule. That's it. Forget we do have to evaluate it. Okay, so if I plug 0 and you agree that that's just 1. Okay. But this is 0, correct? So really all we end up with is, this is 1 to the 4n plus 3. What's 1 to the 4n plus 3? It's always 1, right? So all we really end up with is this. Kind of funky, it got rid of the variable there.
Wouldn't that be negative though? Should be. Because it'd be 0 minus,
So it's 1
oh, right.
over that minus the 0. So there's your series for J. You can calculate if that converges and a calculated value, right? But this is all we're asked to do, so we're doing stuff. What test might you use for a convergence test? It's none of the easy series, right? It's not geometric, it's not a P series, it's not an easy ones. What have we used a lot with factorials? No, that would be an exponent, then. It's the partner to that. Ratio test. That's probably what I would try first. All right. Well, I'm good. So, that's series. That's all it. We're done with series. We decided to leave. Okay.
And that means test.
We have a test Thursday. So put your nose in those memorization cards. It's going to benefit you as much as anything else. And get your strategies for testing these things. Half of the test is series. The other half is everything else we've done this year. Okay. You have the homework, or do you want me to write it down?
Could you write it again? I did it last time.
I didn't write it last time.
Yeah.
We wrote it as we were walking up door and then yelled it in the classroom.
Hey, it's on the Google Classroom.
I was 5 years old, I didn't care.
Yeah. Oh, she went all the way over here. Oops. I'm serious.
Long mouse. There you go.